There's a little preview of some things to come. Welcome back to developing 2D and 3D games with Windows, with Unity on Windows. Welcome to day number 2. We also have a great day of content for you. I'm just as excited today as I was yesterday, and I was pretty amped yesterday. So this is going to be a good day. We've got all sorts of great topics, but Matt, a little bit about yourself first.
So I'm an indie game designer. I have my own studio called Subscience Studios. We're based out of Orange County, California. Recently completed work on a game for the band Avenged Sevenfold, coming out soon for all mobile devices. Before that, I did a game called Grave Stompers, which was kind of a zombie-based game, which fits in nicely with what we're doing today. You can check that out on all devices. And then, I've worked as a digital artist for about 12 years in the industry. Started in music and entertainment back in the day, kind of got into websites, and then fell into games about four to 5 years ago, and I've just been doing it ever since. So, love games and excited to show you guys what we got going on today.
Pretty cool. And definitely check out your website, MatthewNewman.net, where you have some cool tutorials up there. The Rhino, I think, is going to be posted up there from yesterday.
Yeah, the Rhino from yesterday. So if anybody saw what I got started with yesterday, we're actually going to have the full version of that up. Probably, by the end of the day today, we'll show that off and people can download that. And also, there's a lot of speed painting tutorials and stuff like that if you want to see that. But anyways, let's get started. And
I'm Adam Tuliper. I was here for a lot of the day yesterday, going to be here for a lot of the day today. Great day. I'm a technical evangelist with Microsoft. I'm out of Southern California. Been working many years as a software architect. Check me out on Adam Tuliper at Twitter. And why don't we get rolling to talk about some really cool stuff and where we're going to go with the day today. We're going to start with optimizing your games. Then we're going to go into ALM and Unity, learn about Visual Studio Online and source control with Unity. Tobias got a great talk on marketing and monetizing your application, an area that developers greatly lack in. Using Prime 31 to connect your Unity game to Azure comes in Module 9. And finally, in Module 10, adding the finishing touches, integrating with things like live tiles and some platform features to make your game just pop a little bit more.
Cool.
All right, let's get started with optimizing your game, shall we?
Yeah, the single most important part.
Before
you ship your product or anything's done, you always have to optimize. And that's just to guarantee a couple things, right? One, you want to make sure your game runs super smooth, and this is the best way to do it. You want to make sure there's no hiccups or any extra memory hog issues, anything like that. This is what optimizing your game is all about. So there's a couple of topics we're going to copy on this, but I think to start, we're going to go over baking lights.
Baking light, we're going to do optimizing draw calls. We're going to be doing compression, coding techniques. We're going to be talking about terrain and skyboxes, and reducing geometry. Now, this is not a completely all-encompassing list, but these are some good things to get you started.
Yeah.
And so let's go ahead and start with Baking Light, what Baking Light is all about.
Absolutely.
So Baking Light in Unity, there's a third-party engine, Beast, from Illuminate Labs. This, essentially, Baking Light calculates lighting for all of the static objects in your scene. Static objects are objects that aren't going to move, as opposed to ones that are charged with electricity and shocking during the winter. These are static objects. They're not going to move anywhere. Calculates the lighting for them, how light is going to hit them, and opposed to doing it at runtime, calculates it all ahead of time, saves it out to a texture. So the pros for that is it gives you much better performance because it's not having to do all these calculations at runtime. And while hardware has really come a long way and it can do a lot of this at runtime, it's better to save it for the cooler stuff in your games, like little zombie guys running around and stuff like that.
Absolutely.
The downside of this technique is it takes up potentially a lot of space to calculate. You'll see in your project, it can definitely grow quite a bit, and it also does not apply to dynamic objects.
Yeah.
This is just static, but we are going to talk about dynamic objects with light probes and how to handle light probes as well.
There are some techniques to kind of fake that whole process, but make it seem like it's actually running in real time, which is great. So we'll show you those as well.
Let's talk about the process here. Very important to do things, for the most part, in this order. And so it seems sometimes when I go through this, I kind of miss a step at a time. So it's good to have it kind of written out. Must mark all the objects that you want lit up as static. And we'll show you a demo of this shortly. If you don't do that, they're not going to be included in this little map that Unity is going to create. So if you want dynamic lighting, then you need to place what are called light probes around your scene that detect how the light is going to hit those points at various times for your dynamic objects. And Matt's going to show off a demo of that shortly. The other important thing is turn down ambient light in your scene. Now, Matt, why would you want to turn down ambient light?
So your ambient light is kind of like you can think of it as like the shadows in your scene, right? The darker you make your ambient light, the darker your shadows are going to be. It's kind of the places that aren't lit, essentially. There's a lot of cool things you can do with ambient light, and a couple of those would be, you can actually change like the whole tone of your level just by changing the ambience and changing the darks and the color of the darks. Maybe the darks aren't essentially black, maybe they're more of like blues or reds, just to kind of give it a different feel. Things with that work great are when you're doing like daytime lighting, or if you're doing like kind of mood lighting in different settings for night and stuff like that. Yeah, absolutely.
Set the mood of your game.
I mean,
that's right.
Essentially, yeah, you're creating mood lighting for your game.
Candlelit.
Yeah, no, absolutely. Yeah, candlelight. You probably want to do like nice, like dark
got
reds and stuff. Yeah, absolutely.
Dinner on my mind already, and it's still early morning. More importantly, what are we having for dinner today?
Yeah, right.
So then you'll want, after you turn down your ambient light, so kind of like the background, the glow in your game, Unity always has a little bit of light color in your scene. So you're going to turn down the ambient light, then you're going to set your quality settings, because you can really define on how hardcore you want that light calculation to take place, how good you want all those light and shadows to look on there.
That's something to keep note of too, because when you work on the quality settings of the light, that it really depends on the PC you're using too. If you're using like a really, really hardcore PC and you want to really get amazing lights baked, crank those settings up high. It's going to take a while. It's going to take you hours probably to get a really, really nice. Yeah, the higher the settings, the longer the baking process takes. But if you're using like, a laptop that's not exactly, up to snuff as like a rendering machine or anything like that, maybe crank the settings down to do a quick bake. But what that'll do is that'll give you an idea, right? And when you're looking at your level, which we'll go over when we go over the demo on light baking, you're not going to get an exact result of what the baking is actually going to look like when you have your finished product. It just kind of gives you an idea even when you're not baked. You're just kind of getting a loose reference. That's why you want to do a quick bake at low settings, just to kind of get an idea of what the lights are going to look like. And you're going to have little refraction errors and different rendering errors in there, because when the settings are so low, it can't process all that information.
It's
right?
a trade-off. Those maps are smaller.
It's a trade-off. You have smaller
faster.
maps. Exactly. So the memory, it's not going to do it exactly how you want it, but it's going to give you a good idea. So I always recommend, when I'm doing my baking, first thing I do is when I'm baking, what you're doing, it's actually like baking. Like you're putting something, you're setting a timer on it, you're letting it go, and then it finishes, right? And you get the finished product.
We're going to put in our cake into the Unity oven and cook it at 350.
Yeah, exactly.
Cake, food, dinner.
But baking takes a while, right? Just like normal baking takes a while. So you want to do a quick bake first, kind of just see what it's going to look like, and then once you kind of get an idea, okay, that's going in the direction I want, it has the colors on there I want, then you can crank those settings up, or maybe go to a higher powered machine, really put some heavy settings on there, and get a really good bake done. And I recommend that for just before you go to production, right? I mean, not production, but release, right? When your release candidate's almost ready, that's when you want to take the time and get those really, really great light bakes going. And that's like your massive light bakes for your levels, like the overview light bakes that encompass everything, right? And it's going to take hours to get those done.
What's the longest that you've ever had to wait for light to bake in a scene on a game you've worked on?
I think the longest so far, I've only been doing mobile, but to get really good ones, I think the longest one I did was like 12 hours.
12 hours?
And that was like a really, really complicated level with lots and lots of lights.
I'll bake this, I'll get thousands of lights. Back, this will be done, and we're just waiting.
Yeah, like the shadows were out of control. There was all kinds of things going on. So
after you bake the light, one of the important things to remember, turn off the lights in your scene when you're done baking.
A lot of people forget to do that. So what you want to do is, after you do your light baking, you've got this really great, well-baked scene, which is essentially, light baking, I don't know if people know, what it basically does is it's applying almost like a vertex color layer over all of your geometry. So it's essentially faking a layer of lit color over everything. So it appears that everything's lit, but essentially it's not. It's just kind of faked. And nobody will know when they're playing the game, right? Unless you're doing dynamic lights and like the sun's moving from one point to another, that's when you're going to use actual lighting. And even then, you might do a combination of light baking and some type of other dynamic lighting system. But one of the things you really want to remember is, after you get that light baking done, always go in and turn your lights off, because you're not going to need them. Like it's just extra. There's no reason to have them there, unless you're going for a specific effect that requires those lights to be on. But if you're not, turn them off. It's going to look great, and it's going to run a lot faster. You're going to save on a ton of draw calls, and your game's just going to be sped way up.
And turn your ambient light back up afterwards. So beforehand, you turn your light down,
Cool. Yeah.
and then bake it, turn your lights off, turn that ambient light back up. So you got to remember that initial value, and you'll demo that when you kind of go over this here.
Yeah, and I would say I always do forget to turn the ambient light back on, but you'll notice right away when you play your game and your characters look very dark or the color of like the shadows, and you're like, what is going on? When you do light probes, you won't notice it as much, but definitely turn that ambience back up because it's going to do two things. I think it's, from a stylistic standpoint, it's going to kind of improve the visibility of your characters and overall characters in your scene, and anything that's dynamic, you're going to see a little bit better. So it's a rule of thumb for me. I always go back in, have a little note to myself, go in, turn that ambience back up, and then you're ready to go.
So
turn those lights off.
This slide deck sheet that we have here, print that up and tack it to the wall.
Yeah, absolutely. It's a good rule of thumb. Yeah, absolutely.
Remember, all the red. Turn off lights in the scene. I should actually highlight in red there. Turn ambient back up. So let's go on and move on to a demo for baking light and setting light probes, and we're going to switch over to Matt, and I think he's going to show us how to do that in a scene inside of Unity here.
Okay, so
Looking scene.
If anybody didn't see this yesterday, this was our demo project we created for the Virtual Academy lesson. This is the zombie pumpkin slayers.
Yes.
And
ZPS in the house.
ZPS, yeah, we kind of came up with this at the last second, but just a quick overview. The game's about a zombie protecting his graveyard from invading evil pumpkins, right?
Pumpkins.
So for the demo, we made a quick little graveyard scene, and it's just kind of a straightaway right here with a central element that you're here to protect, which is your cross. And what we want to do for this purpose of this demo is we want to light bake this scene and make it look great, right? So what I did was, you'll notice in here I've got a couple lights, and these were kind of like mood lighting elements that I wanted to highlight certain things. And you're going to notice that when you're light baking your scenes, you're going to get like, a rough kind of representation of how the lights are going to look. It's not going to be exactly how the finished product's going to look when you export, but that's why you do baking, because baking is going to give you that final result. So what I do is in here, you can see I've added all these lights into my scene. And this is to kind of give my scene a certain type of look, right? I wanted the directional light, which is your main light. I wanted that to be a certain way so that the shadows were cast across the area that you're going to run, just to kind of give it a feeling, another feeling of ambience. And maybe the moon is kind of where you're looking from. I wanted to add kind of more of a green tone, because from a stylistic standpoint, I thought that just kind of fit with what we were doing. And just little kind of lights here and there just to kind of dress up the mood and what we're doing. I kind of added this warm light right here from these fake God rays that I put into the scene.
So to be clear, those are just... Explain what those God rays are.
So essentially all it is just, it's basically, you're protecting this element, right? And I wanted to create a visual piece that kind of identified that element in the center of the game. And so all those are is just a nice visual element to kind of guide you of, this is the thing you have to protect, right? This is the holy element that is the center of your protection of your game. So your zombie has to defend off from the pumpkins that are coming in and trying to fight this. And
what are those made up of? What exactly are the God rays?
So all this is just a fade in Photoshop in the texture over my UV shell. So I have a UV shell, and I just did a little fade graphic on it and exported it out as a transparent graphic on a PNG. Use that. When we get into optimization, I'll show you how I used the fade graphic for those little rays also on my plants and everything else, which is part of optimization. You want to cram as much stuff into a texture as you can to save on draw calls. But from there, let's get into the light baking and show you how light baking process, how it actually works, right? So we have these different lights in our scene, right? We've got these point lights kind of for little mood lighting and highlight areas. I kind of want to highlight the path a little bit. We have a directional light, which I chose kind of a bluish color because it's nighttime. Wanted to give it almost like a moonlit kind of feel.
And the directional light is kind of like a sun in the sky in a sense, a little bit of...
Exactly. And I usually use 1 to 2 directional lights in my scene, depending on what I'm doing. If I'm doing like a space kind of thing, you have light kind of going in different directions, so I'll probably use 2 different directional lights, maybe cast in different directions. Whereas if I'm doing like a daytime or nighttime scene, I'm going to use 1 directional light just to kind of get that main source of light from your outside, wherever, into a scene where you can cast your shadows, really see those shadows nicely.
Cool.
So for here, we chose 1 directional light. We kind of did a bluish color. Wanted to cast it, make it look like a moonlight. And then I kind of just added some extra point lights to give it, a feeling, a style. I didn't want it to be just blue, just moonlight. Wanted it to feel like, it was kind of this zombie-ish cemetery. So I figured green and blue worked really, really well for that. So let's get into light baking, right?
Yeah.
So what we're going to do is, now that we have our lights in our scene, what I like to do always as a rule of thumb, anytime I create lights or main lights that are going to be baked into a scene, I always put those in a folder called lights, right? And what I do, and you can even write a note to yourself on that, like, for example, always turn off before build, right? And that's just to know that, like we said before, you always want to turn those lights off right here. That's your lights. There's your lights folder. There's all my lights inside. I've got my directional light and all my point lights. You want to turn that off right before you do your build, right? And even when you're just testing, you want to turn those off too, because you want to keep them on, an eye on your draw calls and things like that.
And by turning off, can you show kind of the little checkbox in the upper right-hand corner there? Maybe zoom in on that so the folks can see that.
Absolutely. So you'll see I have my lights folder selected here, right? And if I want to turn those off, right here, where my lights are in the inspector, there's that little checkbox right there. All you have to do to turn those off is just click that off. And then you see my lights go off on the scene. You can see right now, because I haven't baked my lights, there's a pretty dramatic difference between having your lights on and having them off.
Definitely.
So as I turn them on and off, you'll see on, you see all the lights, and you can even see the rays and the radiuses of all those lights and where those lights are being cast. And you can see them off with nothing but the ambience of the scene.
Lighting makes such a difference.
Oh, it does. Absolutely. Absolutely. And there are times, some people, there are reasons to not even use lighting sometimes. It just depends on what you're trying to accomplish in your project. So for now, for what we're going to be doing is, like we said, light baking. So let's turn our lights back on. You make sure here that you've got those on. Always make sure that your lights are check marked. Again, put them in a folder, kind of like I did, and that just helps keeping things organized in your project, because when you start getting 4,000 to 5,000 things in your project, you really, really want to start organizing them and putting them down. I mean, in our environment alone in here, you can just see that there's tons of stuff that we have in this environment. Yeah. So it's just a good idea to really start organizing your things and putting them in different folders.
Just create a game object, drop them all into that game object, and away you go. Organize.
Absolutely, absolutely. So to get started with light baking, all we're going to do is we're going to go to Window, Light Mapping, and that's going to bring up this light mapping window. And this is essentially the window you're going to do all your baking in. And we just want to make sure that we have all our lights selected, which they are.
And to clarify, I think baking is a pro feature, if I recall correctly on here.
I do believe that's correct, yeah. Baking is only available to the pro versions of Windows, of Unity. So just make sure that if you want to do light baking, that you are using that pro version.
One of the advantages of pro version. So we're going to kind of do a mix of things today between some pro, some not pro. So just keep in mind, some of the things we are showing today are pro. Some of the techniques are not pro.
Absolutely. So when you're in this light mapping window, the next thing you're going to want to do is go into the Bake tab right there, right in the center. Go to that Bake tab, and then you're going to get all these different options. And to start, we've actually kind of reduced the amount of options that are in there, but I think when you initially start, this will probably be the lock atlas and the resolution settings will probably be at 30 texels per world unit, I think is the default. And then, if you can see right there, when you initially open it up, that'll probably be at 30. I've actually knocked that down to 2 because this is more of a mobile kind of simple game, maybe a browser-based game. So I definitely want to reduce that. And what that's going to do is essentially the higher that resolution is, the more light maps it's going to produce, right? So when it's set at 30, it's going to know that, I can go all the way up to 30 for the resolution of these light maps I'm going to create.
It's going to take a lot longer.
Yeah, and what it's doing is essentially it's creating 1024 by 1024 resolution images that are your light maps that are using to layer over this entire project.
Oh, cool.
It's taking all those UVs and making these basically shaded elements that fit over everything. So what you want to do is, just as a rule of thumb, just get in there, knock that down. Especially when you're making a test light map, it's a good idea to knock that resolution down too. Your gather rays, I think when it starts, it's set at 6,000 or 8,000, or maybe 4,000. I know it's definitely higher than 1,000, but you want to knock that down too. For a rule of thumb, for me, 1,000 always seems to be a pretty good start. You could go even lower than that if you just want to test, but I'd say 1,000 usually gives you a pretty nice result to start, and it's not too taxing on most of the machines I've used. So you want to kick that down to about 1,000 as well.
Oh, cool.
And then from there, I usually do, to start, I do dual light maps because the result is a little better. But if you're doing a mobile project, you probably want to change it to single light maps. And that's just going to give you one light map, right? It's going to try to reduce everything into one light map. And that will change when you change the resolution too. It will actually make more light maps depending on how many you have. But for now, let's start with dual light maps. Let's set the quality to high. I've never really experienced too many problems of setting low or high quality, so that never really seemed to be an issue for me. But to get started, we'll show you what you do. Once you get those settings set up and you have your resolution down and your gather rays, which are essentially all the rays from the light shooting in different direction, turn those down. We'll knock those down to 1,000. You just want to click Bake Scene.
Actually, you know what? I believe I misspoke on something. It was reversed between this one and the next one. I think the light mapping is included in the free.
Oh, okay.
The static batching is a pro-only feature.
Oh, okay. Well, there you go. If you have the free version, you can light bake away.
Very cool.
So if you're following along, so here we are right now. We're in the bake settings. We've reduced our gather rays. We've reduced our resolution settings. And now you just want to go and you want to click the Bake Scene button.
Bake Scene.
And you'll notice in here there are a couple different things. There are a couple different options. There's selected probes. You can actually bake objects alone by themselves if you just want to bake a particular object. But for now, we're just going to bake the scene. And we'll get into baking probes a little bit later in the optimization module. So for now, we click Bake Scene. And you'll see it brings up the exporting to Beast dialog, and then it bakes the scene. You'll notice there's not a lot of progress things happening. You don't really know like what's going on. Just look in the corner, and you'll see this little progress area, which basically tells you it's being light baked. And for now, I got these two light bakes. It gave me 2 light maps, right? But you'll see they kind of look a little light. And on here, I'm not really getting those shadows that I really wanted. If you notice when I had the preview, I could see some shadows and some different things. And that's because my ambient light was not set. And these right here, these are dynamic shadows. These really, really dark ones those are dynamic shadows being cast from the lights that are currently on in the scene. So you know that those have nothing to do with the light map that's being baked. So what I'm going to do is I'm going to rebake this light map, and I'm going to turn my ambience down. And it's a good thing that I did that because you see how light the light maps are. That's kind of a good indicator that, oh, my ambience was actually too high. So what you want to do is go into your edit up here. And then in edit, you want to go down to your render settings. Once you click your render settings in your inspector, you're going to get all these different options. Fog mode, linear fog, ambience. And this is what we want to concentrate on, is your ambient light. And so from your ambient light, you'll see it's kind of a light gray color I have in there now. That is what we talked about. That's kind of like the ambience.
Setting the mood.
Setting the mood. So what we want to do is we want to go in there, just click in the color of the ambient light, and it's going to give you this color box dialog, right? So if everybody does that, you'll get this, and you'll see it's set to, right now, this kind of light gray color. And we want to turn that down. So we open that back up. Let's do kind of like a darkish blue color. So we'll take this slider and move this down to about right there. Select that, and you'll see my ambient light is now a dark blue, and I'm just going to rebake my scene really quickly with that new ambience light. And if you can see the scene now, let me just back up.
You're just trying to move this to a darker color.
Yeah, I really want to get those shadows, right? I didn't get those shadows last time, so this is what this is going to do. So you'll see I don't really see those shadows, but I want to see them. So now we're going to rebake this, bake the scene. And you'll see it has your little calculation in the corner. It's baking the texture.
Baking. 350 degrees for 7 minutes.
And now you see it's a little bit darker.
Look at that.
And the resolution of the shadows isn't great, but I can definitely see them a lot better. And that's because I knocked my resolution down so much, right? So I'm not getting that super high-res shadows, crisp shadows that I wanted to. The higher resolution you make this, the more detail you're going to get on those shadows. So for now, the longer
it's going to take.
Exactly. This kind of gives me more of that mood I wanted to go for. It's more of a nighttime look. Kind of gives me that kind of zombie feeling.
It's well with Zombie Pumpkin Slayer.
Exactly. So there you go. You have your light maps baked. And then from there, after you've got those done, you can look at your light maps. See, it gave me 2 light maps right here. You can see my bake settings, what I had. And sometimes it's a good idea just to write down the bake settings you used. If you do like a particular setting and it works great, just write down those values and just have it as reference to use later on. So we'll close that window. You can look at our lights and see how it turned out. It looks pretty good. Then you want to go to your lights, and you just want to turn off those lights in the scene, right? And you see now I turn off those lights. I have all the lights baked. They're on there. It appears that the lights are still on, but they're not, right? The lights are turned off, but you'll notice my characters are dark, right? And that's a good indicator of the ambience. The ambience is still too dark in the scene. So from there, we want to get this character lit back to kind of our normal standard so we can see him. What we'll do is go into our render settings, and then under the ambient light, like before, we're actually going to click that color, and we're just going to bring that back up. And that's because this is a dynamic character. He has no lights on him right now, right? So we want to bring that ambience back up. So first of all, we can see the characters.
Sure.
And if we decided not to use light probes, it's a good way to kind of pump up those values of the characters not using. It's great for animated characters or characters that aren't getting a lot of light in a certain game. Bring that ambience back up so you can really, really see them. They'll pop out from your scene. So from there, we've brought that up. He's now has his ambient light. We can see the character. And I think that's exactly how you do just basic light mapping. And then from there, are we going to...
Why don't you talk about the light probe script and the light probes?
Absolutely. So we'll talk about light probes. So now it's like we have our characters lit, our scene is light mapped, but we want to cast some light on our characters. Like we're just not super happy with how the characters currently look in our scene. They wish they could actually get some of that greens and some of that blues as they run around. Maybe as they go under these god rays here, they kind of get lit up a little bit. We want those kind of things happening to add a little bit of drama and just kind of feeling to the scene.
Realistic.
Yeah. It just makes everything feel a little bit more complete also. You just want to have those different elements. So what I'm going to do is, for the purpose of what we're doing, I don't think I have too many lights actually in the row of what I'm doing, so I'm just going to bring these lights back on. I'm going to build another just dramatic light so we can see exactly what I'm talking about.
Okay.
So for right now, let's just take this this extra light I have. We're going to duplicate that. We're just kind of going to bring it into the path of where these characters are going to run. So right now they're running down that way. We're going to put it in the front. And basically what this is going to do is it's going to show these guys lit up as they run by it, right?
Cool.
And for now, let me just do it as a color so we can really, really see the difference. So I'm just going to do like this really, really orangey color just for the sake of the demo and what we're doing.
Sure.
So you can see that, so you can see the process
Plus,
happen.
it's very Halloween-y.
Yeah, exactly. So we'll kick that orange color up. We'll increase the intensity. These are your colors of your lights right here. So you just want to make sure you increase the range, increase the intensity. And as you're light baking, you're always going to want to be going to your different lights too and changing those settings and keep baking and rebaking and getting the result you want. It's all about playing with the lights and trying to get that feel of the game. So, we'll increase the intensity pretty high on this. And the range we're also going to increase too, because we just want to really see the effect of what the light probes do to your characters. And this is just a dramatic way of showing that. So we'll increase that. Maybe I'll make it more of like a yellowy color, kind of like that. And we'll increase that, increase the range of that point light. And real quick, I'm just going to go back into my light baking settings. And now that I have my lights back on, I'm going to do a real quick rebake just to have that new light in that new bake we did. So we'll bake our scene. You'll see now it's going to rebake the scene. Oh. You know what? Actually, let me turn that ambience down. Like I said before, you always forget
steps.
Always forget about that ambience. Go back in your ambience, turn the ambience back down.
The good news is if you happen to not catch that slide, these are going to be recorded and online in a couple weeks, and you can go and take a screenshot or download a slide deck and tack that up on your wall.
Absolutely. So you can see I brought the ambience back down. Now I'm rebaking the scene. It's calculating, doing its work for the light baking. And it's baking the texture at the moment. And now the light bake is done.
Cool.
And you can see right there, see the result of putting that light in there. It kind of gave this really intense kind of lit area, which is kind of nice because that's our goal, right? We want to protect that. And so that gives us a kind of a beacon for our characters to know where they have to go. Now we'll turn the light mapping off. We will turn our lights off. We will go back into our ambient light. And this is kind of like a 2 to 3 step process every time. You want to turn that back up, bring those characters back.
Sometimes it helps to write down those initial values that you have just to get them exact before and after, so your scene kind of stays the same. But
absolutely. And then you'll see, okay, I've brought the ambience back up. Now I want to do some light probes. And light probes are a very tedious process. So it's not something that happens quickly, but there are some scripts available out there that make it much, much easier.
Normally you have to place them all by hand.
Normally you have to create a light probe, you have to grab that light probe, create another one, and space them equally apart in huge areas of your project, and it takes forever. But there are some really great scripts out there that people have written to make this process much, much easier. And one of those scripts I found was this script called Light Probe Helper. And you can find this script for free online. Just look for it in the Unity forums and stuff. Everybody knows where it is. You can get it. And then from there, you download that script, you put it in your project, and you're going to make a game object called Light Probe Group. I just called it light probe group for the sake of the project. You can call it whatever you want. And you attach this script, which is your light probe generator script. I think that's the name of the script, light probe generator.
Light probe generator.
But I think if you just light probe helper,
yeah,
you will find it.
That's how I found it.
Most people know it as light probe helper. Add this script, light probe generator script, to your light probe group. And then I think on your light probe group, you also want to go to components, rendering, and then you want to make it a light probe group.
And that adds that other middle component underneath your transform over there.
That brings this one up right here. So right now, it'll actually come on when you actually add that light probe group to that light probe group that you created in there. So create your game object, go to component,
and it tells you that when you download the package, there's a little...
Package has some instructions in it that kind of give you those instructions, but you want to create your game object, add that light probe group, and then you basically right here, you'll see that it puts this light probe generator script in your game object. So from there, you'll see in here I have all these light probes, and what that script did was actually take an area. It lets you define this square. You have like the positioning of the square, and then you have a dimensions of your square, your X, Y, and Z variables. And if you go in here, you can kind of see right here in your probe volume, it gives you the
text
space.
Kind of gets a little scrunched in there, but that's the... talk about those values there?
Absolutely. So, yeah, I don't know what's going on with that right there. But basically, it tells you the center values of where this volume of light probes is going to be. And you set those values. And then these bottom ones right here are going to tell you exactly the size of this kind of volume of light probes that you're going to make. So really, and trust me, it seems a little tedious, but using this is so much easier.
It looked like hundreds of
You see, doing that by hand would just be... It would take forever.
Wow.
It would take forever. But some people do it. Some people do it. So anyways, get this script. It's really, really going to help you out. Once you generate, you do those values, and you have this kind of, if you'll see right here, I have this big red kind of outlined volume. It's going to make that volume. You want to center it along the area of where you're going to put all these probes, right? So right now, for the sake of what we're doing, I actually already pre-generated these probes, but when you're doing this before, you're not going to see those in there. Once you do that, you're going to click generate, and it's going to create all these probes within this grid. And for the sake of time, I already have those in there just so you can see what it's going to look like when you initially do that.
Cool, okay.
So make sure you get your grid set where you want it, and that's that red box you're going to see right here. Once that's done, then you click generate. Then you're going to get all these probes within that volume that you created. And basically what you want to do is just put those probes along the path of where your characters are going to run. And don't worry about having the probes go underneath your scene or anywhere else. You just want to make sure that they kind of more or less fill the area of where any of the characters or anything that's dynamic is going to be moving within your scene. And then from there, once you have all those light probes set in the area that you want, you're just going to go into your window settings, go back to the light mapping window that we had before, click on the Bake tab, and then instead of doing Bake Scene like we did before,
let me guess, Bake...
We're actually going to go to Bake Probes. And then you click Bake Probes. It's going to go through its process, and then it's a lot quicker than making the scene.
Wow,
it's already done, but now we have our probes baked. And so from there, you can actually... You want to keep your light probe group off, but just click something else in your scene and you won't see all those light probes. You're only going to see those if you click on that light probe game object. And be aware too, the more probes you have, your scene will start to run very, very slow. So if you have a bunch of these different volumes of light probes, I recommend doing the same thing I do with lights, is I would throw them into a game object, because if you have a bunch of these, your scene's going to run very, very slow. And this is one of the things you want to do probably near the end of when you're actually going to go to release. So just be aware of that. Sometimes it crashes if you have a lot of light probes. If you've got thousands of them running at one time, it will crash.
Okay.
So just be aware of that. It's just kind of a good rule of thumb. But anyways, now that we have those, we can test the scene out and actually see these light probes working. So, you also want to make sure on your characters, anything that you want affected by your light probes, you want to click on those characters, click on the model of the characters, and there's a little option under your mesh renderer. You'll have cast shadows, receive shadows, and then make sure use light probe right here is selected. There's this little option right here that says use light probe.
Got to be checked off. Or
that has to be checked off, or they will look like nothing's going on.
Okay, cool.
So with that being said, we'll test our scene. and just enter your play mode. And you'll see my little guy right here. As I run, was he being affected by the lights? Does it run through here?
Was that light off when you baked it? When you...
No, it should be there. It should be, actually, here. Good way to test is we can bring our ambience down and really see if these light probes are being affected. So right now, actually, it doesn't look like he's being affected by those lights at all. So what we can do is go back into our light probe group. Let's make sure that everything's working.
Recheck the settings.
Yeah, recheck the settings. Make sure everything's on. You want to make sure your light probe are working. Let's regenerate just in case. Generate. Light probe's working. Okay. That's working. Let's go back into our window settings. Turn our lights.
Sometimes there's a bunch of steps. You got to make sure every step that you get.
There's always a bunch of steps. There's always 10 steps to make sure something happens. You always want to make sure you recheck to make sure it's working correctly. Make sure your lights are on. Go to window. Go to our light mapping. Go back to our. Just to be safe, let's bake the scene real quick. We'll bake the probes, and then we'll also. Okay. Go back in. Look like those are good.
I'll tell you what, while you check that out,
okay,
we'll cruise on and start talking about reducing draw calls, and then we'll switch back to that demo a little bit towards the end. So since we got a lot of subjects to cover here today, we'll move on to the next one. We'll start talking about optimizing draw calls. You can check out that scene, and we'll loop back to that momentarily. Sound good?
That sounds great. Let's do it.
So, optimizing draw calls.
You know what? You can see it here. Yeah.
All right, perfect.
You know what? I think my lights just aren't as intense as they should be.
Okay.
But if you'll notice my character, it's very, very subtle at the moment. I don't think my lights are as close to the character as they should be. But you'll notice even when I run through this green right here, you can see that he's subtly being affected by those green lights.
Yeah, I saw it right when he ran kind of on top over there.
Yeah, and you can see here, he kind of actually gets hit right there too. And that probably has to do with the fact that my lights aren't as close to the character as they should be, and the intensity should have been brought up way, way up. But yeah, you can see as I go to the end right there, he actually is being affected. It's just a very, very subtle lighting effect. So that's just, I should just turn my lights up and that's what you want to do. You want to play with your lights and get the result you want.
Okay.
So what I'll do is, Adam, as you're going through your next thing, I'll just kind of turn those up and show what that looks like.
Perfect.
So they get an idea.
All right. Thank you.
No problem.
Cool. All right, let's go back talking about draw calls. Draw calls are one of the several major things to look out for. A draw call happens when there's a call issued to the graphics API to draw an object. And I like to think of it as the computer has to render out your scene. Every time you have to paint out a texture, it's essentially like changing a paintbrush. The system is really drawing with textures. Each model, typically by default, without any kind of optimization techniques, has one draw call. It's going to be constantly switching from one texture to paint this object, one texture to paint another object. Now, draw calls affect CPU. The more draw calls you have, the more your CPU is affected. So on mobile, you typically try to target about...
On mobile, I try to, depending on the device I'm going for, if I want to cover all devices, you want to stay within that 50 to 90 kind of range. 90's pushing it. Maybe you only have some hiccups here and there where it spikes up to 90. But as a rule of thumb, in general, you kind of want to keep around 50 to 60.
Lower
devices, you want to keep around 30 to 40. I wouldn't even go higher than that.
Gotcha.
And that's just, this is what optimization does. A good way to really tell if you're getting those draw calls or not is within Unity, when you test your game right here, if you want to look at my screen, as I test my game, you'll notice that there's this little window at the top called stats. You'll see that right here. What you want to do is click stats and you'll see in here the draw calls. So right now I have all my lights turned on my scenes. I'm going through it, rebaking, and you see I have some dynamic shadows from all the enemies. You'll see that draw calls right here is really, really high. And that's because I have all those lights happening on the scene at once.
So we're going to talk about some cool ways to reduce those draw calls.
Absolutely. And if you're doing next gen work, it's okay to have those. You can have thousands of draw calls.
But mobile's different.
But mobile is a totally different beast. No pun intended.
So reducing draw calls is the key.
Yeah.
Definitely, that's the target there. You want to reduce draw calls.
Yep.
So let's talk then about atlases on the slide deck. If we take multiple images and we pack them together to a larger one, That is what we have as an atlas. You'll hear in game development texture atlas or atlas a lot, and that's essentially nothing more than taking multiple images, adding them to a larger one. And so as opposed to the system painting these separate textures out and having to load up multiple textures, it has one texture and it can just map to different objects. Like one, you'll show when you do the Rubble demo, part of that texture, if we look on the slide deck there in the lower right-hand corner, part might be mapped to one object, part might be mapped to another object. So that reduces draw calls. On the UI elements in Unity, what they initially brought out as their new GUI system, and actually 4.6 beta that's downloadable now, that has a brand new GUI system on there. We looked at some GUI elements yesterday in creating a 3D game. Those are Auto Atlas is what it's called. So that kind of packs your images together on the back end just to save on performance. And Unity does have a sprite packer that you can use for your 2D assets to help optimize those a little bit more, and I'll show you a little bit demo of that. But let's talk about some ways to reduce draw calls. In reducing draw calls, static batching. We're going to look at a demo of that. That was what I was mentioning is a pro feature, and that will basically take your objects that don't move, and we mark them as static. That behind the scenes combines your geometry for those objects, optimizes drawing them out. Now, dynamic batching, that is free, in the free version, that works automatically. So those are objects that are running around, moving around. That sharing happens automatically. The batching happens automatically. You don't have to worry about that. But there are a couple things that you do have to worry about. That has to be the same material shared. So if you have zombies running around, those zombies have a shared material. As long as there are less than 900 vertices in that zombie, this will happen automatically. And also as long as those objects don't have any real-time shadows on them. Ideally, you want to atlas everything you can, right? Take your sprites, pack them together, your textures, pack them together. And I know you do this quite a bit, and you'll show that when you look at the Rubble one shortly.
Absolutely.
In Unity, they have the old GUI system. It's still, you can use it in the new versions as well. And that old GUI system, you kind of did things by code. You had an on GUI method. You drew things out to the screen, and that was not very performant, so to say, for draw calls. So we want to try to use their new GUI system. Some folks call it UGUI. In the Unity editor, you actually see it called UI. That's the new one that you want to use. That's definitely quite a bit more optimized.
And that's really, really, really going to help in the draw calls too. I mean, packing all those sprites together as a single sprite sheet, you're going to have a dramatic difference that you're going to see in those draw calls. You're going to go from probably 20 or 30 down to 1.
Let's look at some performance enhancements from reducing those draw calls,
Let's
shall
do
we?
it. Yeah.
All right, so let's switch over to my computer here. We're going to look inside of Unity here. I've got a scene opened up in ZPS, Zombie Pumpkin Slayers. Woo! So I've got the scene loaded up here, and let's go ahead and run this real fast. I think I've got my music turned down. Okay, so my draw calls are really low right now because my lights are off. I haven't done the baking on here. So my lights are on, and let's kind of see here. We've got 190 draw calls right now. That is a lot. Very, very bad for mobile. This will be bad. Now, right now, I've already got some saved because some of the objects on the scene right now are already optimized. Unity is telling us how many have been batched together to save draw calls. So we've got 115 calls that have been batched as opposed to having them on this side. It's saving those. So we want to increase this number and reduce this guy right here. So let's take the environment here, organized quite a bit, and taking all the crosses. So if we just click on the cross here, we've taken all of these crosses and put them under one game object here. Now, these guys will not move at all. So I know I can come in here and mark them all as static. How do I do that? I put them all in a parent game object here, just like you were showing us with the lights. So what I do here, everything is in a game object. I've got crosses, we've got plants, trees, all organized, because that helps us to just come over here. Let's undo this first so I can show you how we do it. This guy right here, static. We want to make sure we check this off. We know these objects aren't moving. You're telling Unity this is highly optimized, it's going to be optimized. This isn't going to move at all. In fact, you get weird effects if you try to move an object that you actually have marked as static. For example, if you were to put a cube in your scene that was marked as static, you would see your collider move, but the actual mesh would stay still. You get some weird effects. So you want to make sure that these things are only ones that stay still.
And I'd say that's a common problem, too, when you're developing. If you attach scripts to certain things that are dynamic and, let's say, have traps in your level or different things that are going to work and they're supposed to be moving a certain way, but they're just kind of acting funny, always remember to go back in there and check that static setting and make sure that's checked off if it's dynamic or on if it's just going to be a static object that sits in your scene.
Good point. Now, because I've got all these child game objects underneath the one called crosses, it says, hey, do you want to enable this for all the children? Yes, change children, that's what that says there. Do we want to enable static flags for the children? This one is what we want, yes. Change children. They're all marked as static. Just like that, let me play the scene here. Notice, so let's go and undo everything here. Check this out. Save by batching, 51. I checked it off. Come back over here. 115. So without it, 51. With it, 115. Now, again, we see these draw calls being so high because my lights. Let's assume I baked my scene. Because right now we were at, let's look at that value again. So I've increased this by checking off static for my crosses. My draw calls are still huge, 193. I'm going to assume my lights now have been baked. Run that again. And now I look at this here. I'm down to 26 draw calls. Very mobile friendly right now. Very mobile friendly. Perfect. Save by batching is lower because we actually have the lights combined with a lot of other objects off now. So that's why we're seeing this other optimization there. All right, now secondly, let's talk about the atlasing built into Unity. I'm going to create a new scene for that. And in here, I'm going to take, I've just got some 2D graphics here to show you what would happen with some 2D stuff. This concept works with really any 2D. I'm just going to take these and throw a bunch into my scene. I'm going to go into 2D mode here, this little 2D button here, just so I can drag and drop my textures into there. These are 2D textures. In a 3D project, when you bring in a texture, it actually comes in as texture type texture, which you can't drag and drop into a scene. On a 2D project, or if you change it on a 3D project, if you want to be able to drag and drop them into your scene, you want to make sure these are set to 2D and UI, in other words, a sprite. Now I can just drag and drop these. As I drag all these in here, notice I'm starting to increase my draw calls down here. Now, I don't have much stuff here, so it's not a ton. Actually, I don't want to create an animation. That's why it's asking me that, because I dragged a bunch of my sprites in there all at once. So my draw calls kind of start to increase here a little bit. So what I can do with all these guys, let's assume I've got many, many 2D assets in here. I can take all of these here, and I've enabled the Sprite Packer. So under Window, we have Sprite Packer. Sprite Packing is disabled. Enable it in Project Editor Settings. So let's go ahead and enable that in Project. Edit, Project, Editor Settings, Sprite Packer. Mode is disabled. I'm going to say I want this always enabled. Now when I go back to Windows Sprite Packer, we have our Sprite Packer enabled here. And I'm going to want to click on this first button there, which is Pack. But in order to do that, I need to have told Unity, how should I pack all these together? You kind of want to keep similar colors, similar groups together. These are all fairly similar. So I'm going to come here, I'm going to tell Unity, all of these guys right here, I want a packing tag. It's just text. We're going to call this platforms. So this is so how it knows how to combine everything together. We'll call that platforms, apply. So Unity is going to say everything with this packing tag of platforms, just text, we're going to squash together into one atlas so we can draw them all out at once. Now we come into the Sprite Packer, now that we've set our packing tag, and we just pack this guy. Pack, filtering out to Atlas 1 of 1. Let's increase the size of this a little bit. And if we look here, now it's taking all those images, and it has one texture with a couple different pages in it. So these are all now on essentially one image, and Unity knows behind the scenes how to map each of these to each object over there. So it's a real easy way just to come in here and kind of pack everything onto there. I mean, of course, I just have a real generic scene here. So that's one way that you can use to pack all your stuff together inside of Unity. You can also do it outside of Unity as well. Prior versions of Unity, the Sprite Packer was in preview mode. That is now out of preview mode. We don't see developer preview only or whatever it used to say on there. In 4.6, it's now just listed as Sprite Packer. So Matt, why don't you take us through, since we've looked at the 2D side, we've looked at batching as well, maybe take us through how you might do something in the 3D world. I know you had a really cool rubble texture on there that took advantage of the 3D laying out into a 2D, right?
Absolutely. So a lot of things I like to do when I optimize the objects in my game, and I want to make sure that you want to have all your objects kind of sharing different textures. Don't have too many 3D objects with all individual textures, because when you do that, those are essentially draw calls, right? So each object you can think of as one draw call. So it's better to take, and draw calls are based on materials, right?
Yeah.
So the more materials I've ever seen, every material you have is essentially one draw call. So you want to try to combine as much as you can. So for the sake of what we did within our demo, we'll look here. Let me just turn my ambience back up so I can see what I'm doing.
Lights are everything.
You'll look that I've got a couple different objects in here. And I wanted to save on the draw calls, because if I had each of these as individual materials, it would be a lot of draw calls happening at once. So what I did was combine things. And this is really great when you use things like transparent elements, right? So for transparent elements, I have a couple things going on. I have my plants right here that are based throughout your scene. And then I have these little God rays elements right here, right? And you'll see what I did in those particular elements.
And normally they would all have a separate texture, each one's separate.
Absolutely, they would.
Each a draw call, they're all separate.
But in order to save on the draw calls, I wanted to combine those elements together. So what I did was in 3D, when I made these objects in 3D, and you can see kind of right here, the actual 3D kind of wireframe I used to make that, I went in to the texture. If we go into the actual plant, you'll see right here, there's two things happening in this texture. I'll try to open that up. And it's a little hard to see because of the background, but you'll see that I have my plant leaf that I painted, but I also put that fade for those rays also in there. So these two objects are essentially changing or using the exact same texture. And the reason these ones are is because they both share transparency. So with transparency, you have a transparent element and you can see through it, right? And the same with the rays are transparent and you can see through it. And I would suggest if there's little elements like that, if you have fades or any elements like that in your scene that you're going to be using a lot of, put them all on the same texture, because those are really going to kill performance and add probably even more draw calls because of overdraw and things like that. So you want to make sure on your transparent elements, you do the same thing. Now for actual kind of solid elements in the game, I did the exact same thing, and I try to be creative with my textures as well. And you want to really think of that when you're creating your levels and doing things. So for the rebel, right here, I have all these rebel pieces on the path as the character runs. You've got all these different bricks and different pieces that sit in here. But for these, I did the same thing. These share the same texture with this giant cross in the middle. So I have this cross, and that's the element you're to protect and everything. But on here, I did a couple creative things. I said, well, this base actually uses the same repeatable texture over and over again, this kind of triangular little piece right here. And then I have the elements I cut out for the cross as well. But then I had extra space on this texture that I created. So you can see right here, I have my cross. I've got the base for the cross, the different pieces. Here's the base of the texture. And instead of using a ton of different sections for that, I just made one, repeated it over and over again, and all those different UVs kind of use that exact same spot. And that freed up a lot of space on my texture that I can use to do different elements. We'll zoom in here so you can see. So over here, I've got my rubble pieces, and those are those pieces I have that are kind of littered across my stage. And then I have some other pieces for more row. I had a lot of room in here to do a lot of different pieces. And so you just really, really, really want to be careful as you're making things. To create UVs, you don't need specific textures for different things. They can all be, if you have room on textures, take a piece and create it in that texture you're already using. I did the same thing with the trees, and that's probably a really good example because you can really see the two defined elements. So right here was the tree I made. And you can see the texture for the tree I made. This was right here. And essentially what I did on that tree was I just made one texture for the bark of the tree, the central element, and then I reused that piece over and over and over again to do all the branches. It's kind of in the distance, you don't really see it. So I have just that one element, and all those pieces are using that exact same element, which is this whole piece right here initially was the trunk that I cut out, and then I used part of that trunk to make the different branches in 3D, right? Cool. And then on that space, that gives me a ton of room, because if you were going to do a tree and have all these different added textures and stuff, it'd be kind of littered across your texture and they'd be all over the place. But doing that gave me tons of room on here to add more elements. So I put a huge boulder in here and textured that as well. So because these two elements are using that same texture and they're marked as static, I have all of these trees scattered around my project. I got one,
all in
two,
different
three,
locations.
all in different locations, different sizes, different, I skewed them differently to make them appear as they're all different, rotate them differently, but they're all exactly the same. And because they're all marked as static, you're getting one draw call because it's batching all of that together. It's basically thinking of that as one material and one thing it has to edit. And so you're basically, I think maybe one, maybe two draw calls it might get, and that just depends on the CPU. But when you do that, you save a lot. I did the exact same thing with the wall back here too. I did one texture for the wall, and with that texture, open it up here, I've got a couple things. Yeah, cool. I've got the wall itself, which I use to do this repeatable texture for the wall, and that's this right here. And then for the top of the wall, I used this repeatable texture right here. And then I took that model and I cut it down and did a variation on it, and I used this area of my texture to do kind of like that broken part of the wall, right? And then from there, I wanted to do a column of the wall too, and so I made this third model. Oh, whoops, get back out of there. I made this third part of the model, which was this column right here, that I used the exact same texture to kind of use the UVs and repurpose that texture to make more elements. So from there, I was able to get three kind of unique models. I did a broken wall, I did a flat wall, and then I did a column with a cross on top of it that are all using the exact same texture. And that's a one draw call. And you have all these elements. You can do all kind of unique things. Yeah, and do really, really cool stuff with it. So that's just a really good tip, and you want to be very cognizant of that when you're building your levels, that you can take all these pieces, combine them, combine as much as you can to build a lot of unique pieces with one material.
And save on performance, because remember that draw calls affect CPU.
Absolutely.
Reduce that all out. Very cool.
And these work really great when you're doing things like castles and other things like that. You want to make sure that you just throw all that stuff into one material that all these objects can use. You're really going to save on your draw calls, and you're really going to get great gains out of the performance of your game.
That's cool.
Well. Yeah.
Very cool. So very important tips to remember.
Yeah.
Let's move on to some other tips that we've got here. Compression. Compression, typically very easy inside of Unity. You can compress inside of Unity per platform. You can figure out which devices you want to target. So if you're going to be going to Windows Phone versus Windows Store versus iOS versus Android, etc., you can change your compression on there. Now, universal apps don't support compression per platform, and I'll show you this in a second. And this affects not just Windows. There's other platforms that have the concept of universal apps. But the idea is that when you want to take one texture, it might be a high resolution on let's say you're going to be running on a PC. If you're going to be running on mobile, you want that compressed down quite a bit. And inside of Unity, let's take some of those textures that I had before, like some of those platforms. If I click on them right over here, Unity shows me the quality right now. So let's say I'm going to build for the web. I might have, right now I have a default size of 1024. But let's say on Windows Phone, I want to override that value and come down to maybe 256. Let's just look at that real quick here. Kind of notice the resolution that's on here. I'm going to override for Windows Phone, and you just drop this value down here. So I'm going to take this just for the effect so we can see it more. I'm going to chop down, that's 3.8 megs. And then how do you change your actual platform to see that? In your build settings inside of Unity, Control-Shift-B or File Build Settings. When we come in and we change them, right now we're defaulted to Windows Store. If I want to go to a standalone build, I would switch a platform there, or down here to Windows Phone, switch platform. Let me actually go back and switch Windows Store since I'm on Windows Store here, and change that down. There we go. Because that's my default platform I'm building for. Now we see the effect. That went from near 3 megs down to 15K, and we can see the size and quality has been reduced quite a bit. So I probably wouldn't use it on anything with a big screen. This is probably a good setting for phone. The idea is on these settings per platform, whatever platform you're exporting to that Unity supports, you can override that per platform and change those settings up a bit. So it's kind of a little bit of experimentation. Alchemy Labs has a really cool product called the Multi-Platform Toolkit, and that kind of gives you an easier way to support compression inside of a platform. So for example, a universal app in Windows where you can have one build that's going to target inside of Unity, you're going to export universal apps for Windows Phone and for Windows 8.1. What you can do is separate them out inside of it. You can say, oh, we're going to Windows Phone 8.1. I want maybe this texture, and if we're going to be going to Windows Store on Windows 8 style, maybe bigger devices than a phone screen, I want to target this size texture. So you can definitely mix that up quite a bit on there.
Just to show you really quickly, if you want to cut back to my screen, what we were talking about earlier with the light probes, this is the effect you'll get. So when you look at your character in the screen, as he runs around, you can see there's kind of that general ambience out here, but as he gets closer here, he starts to light up. So you'll kind of get those vertex shading on your character where it lights up and kind of just gives you a little more of that ambience as he runs around.
I see.
So he's kind of general ambience, and he goes here and he starts to light up, and you can see those colors kind of hitting him. So just, light probes are really, really good to give you that added kind of dimension to your characters and a little bit of shadow and feel to them. So just to show you
some added info. Very cool.
Just some added info to kind of give you an idea of what that looks like.
Awesome. So back to compressing textures. We can change it real easy inside of Unity. Just check those off and change them per platform. Audio is easy as well. Unity supports a bunch of different audio types: WAV, MP3, OGG or OGG. So the idea is that if you have long bits of audio, you kind of want to rethink that strategy a bit. Either you have to highly compress them, and I know you came across this when you were playing kind of full songs on long audio tracks. You found out that you had to really...
Yeah, you want to keep your audio tracks down to basically loopable, maybe 30-second tops tracks, because when you have these very, very long songs that play, it's a major memory hog, especially for mobile devices. You're going to get major, major memory loss that you could potentially use for other things like graphics and everything else when you have all that memory being filled up by this audio. And it also reduces the loading time a lot on your game. So when you have these huge songs, right, that are in your level that you have to load, and you want to reduce that, just put it in a loopable track. It makes it a lot easier. The levels will load up a lot quicker because it doesn't have to load in all that audio at once.
Some folks might notice that on the settings for audio in Unity, there's if we switch back to the slides here, this guy right here, stream from disk. That sounds like, well, hey, I don't have to load it all in the memory. The purpose of this is to to make your game load faster as opposed to have to wait for that audio. It plays faster. The downside is there's a lot of hits to storage, and that is also a drain on your game. So there's kind of trade-offs as a best overall strategy. Like Matt said, you want to keep these clips to lower length, loop them, and then switch in and out other clips to kind of mix it up a little bit, right?
Absolutely. Absolutely.
All right, let's talk about coding techniques next. So in Unity, you can do all sorts of coding optimizations. As a general rule, some folks might say don't premature optimize. So there's all sorts of different tips and tricks and different times you may or may not want to use these. So I'll just talk about some of the basic ones here and kind of when you might want to use them. Remember that inside of Unity as it stands today, you're going in your code from this kind of managed code over to native code back again. So if you say to Unity, hey, I want to do something in code with this GameObjects transform, it's going to the native engine, getting an object and sending it back to you. And anytime you cross those boundaries, you hurt performance. So we're going to show a way that we can cache those up front. When you use techniques like GameObject.find, they scan every object in your game to try to find an object. They're very slow as well. Component references. We looked at in the demo of getting a reference to an animator component. In those, if we're constantly saying, hey, get me my animator component and do this with it. Give me my animator component and do this with it. Over and over and over again, maybe multiple times a frame, that's going to really kind of hurt performance. So you can cache these references up front. We'll get some code ways of doing that. In the editor inside of Unity, we can cache out a reference to there. We did that yesterday in the 3D game. We basically drag and dropped our little text box into the Unity editor, and I'll show you a code example of that. And ideally, you want to avoid lookups and loops. Not trying to go back to Unity and asking for data in a loop, maybe inside of your update frame. Since it gets called so many times a second, you don't want to loop inside of your update calling out as well. And also, object pooling, huge. If there's one thing to take away from today, object pooling. Pool your objects, pool your objects, pool your objects. And you say, Adam, what is object pooling? Well, I'll show you that in code. Let's hop over to a code demo here. Yesterday in ZPS, we were doing things like spawning out all of these zombies pumpkins, one by one by one. These guys all start coming around.
Zombie pumpkins?
Zombie pumpkins. Clear this guy. So all these pumpkins that were coming out, they were all being spawned at several times. I would destroy one. It would go away. It would get destroyed. New ones would spawn. That's very, very, very expensive for performance. Because you have to spin up new objects every time. In addition, you have to... the runtime will do garbage collections every now and then. And when it does garbage collection, your game pauses. So you want to allocate as few objects as possible. The idea is you want to use...
when we were initially testing this, we had the pumpkins just kept coming. There was hundreds,
and my system
maybe 200,
crawled.
300 pumpkins because it just kept spitting them
going,
out.
and,
so it started great. The game would start great. It would run like super smoothly. But then as those pumpkins started coming out and they started filling up the screen, you saw this major performance hit, and then it was like running like a dog. It was just running so slow. So
I got down to like 4 frames a second here.
Exactly. So this is what object pooling is all about. You kind of want to limit the amount of objects that are on the screen at once, and it kind of counts up that, and basically this is what you're doing.
Yesterday, to your point, this is exactly what we were doing here. We're basically coming in here and just constantly instantiating over and over and over again in a loop. Create the number of zombies for us per wave, then we waited a little bit, created another wave. I'm sorry, pumpkins. Zombies on the brain.
Zombie pumpkins.
So this is in the code that you're going to be able to download. I have spawn without pooling. That's what I was doing yesterday. Today, I'll show you my spawn with pooling. And I'm using one here called Trashman, which, just to show you the URL here, was also by the fellow from Prime 31. You can write your own object pooler. You can download a bunch from the net. There's tons of them out here. This is just one. I kind of like how it works. It's pretty easy to use. All you're doing here, rather than getting a brand new object, what you're doing is you're downloading the Trashman component. You're adding a game object to your scene. I called mine Trashman. And you have this Trashman script over here.
Great name.
It's a recycle bin and a trash man. You drag your prefab on here. So I took the pumpkin, dragged it on here, and it created a recycle bin for a pumpkin. Said, all right, how many do you want to pre-allocate? Well, I'm matching this to my wave size. I want 12 pumpkins to come on my screen at once. And here I'm saying, you know what? I don't ever want to go above 12 pumpkins. I'm going to wait until that player has to destroy them, even if it's time for the second wave. What this does is when you ask the pool for another pumpkin, if there's already 12 out, it's just going to return null. There's not one available.
So without having that checked, it'll do 12 at a time, essentially, and then that could add up and be even higher than 12. But if that's checked, it'll only make sure that there's only 12 at once.
Yep, it can go higher. In that case, then it has to allocate more. What I've done in this case is I've said I've got a hard limit of 12. Do not give me any more than 12. Now, this number doesn't have to match the above. I could say start out with 12. I could make this 20, and it's going to cut off at 20. So kind of fool around with that. I'm going to make this match my wave size just for, I think, for performance. It makes sense to me that way. In the code, it's really easy. We say, trash man, give me a pumpkin. That's all we do. And then, let me search here, and I will show you where we despawn. Once we kill a pumpkin, we call its die method, and all I do here is I despawn that. Now, I am kind of, I could respawn my particle systems here. This is kind of a no-no, I would say. I should actually recycle my particle effects here. So right now, Trashman despawn my game object. Now, whenever I want to create a new one again, I spawn it, and then I just happen to reset the values on there. And if I look at my pumpkin here, I just have a little reset value that comes in here, sets its health back to its initial health, stops any running coroutines, just to start those values out again. You always want to make sure you reset your object's health or whatever values you need to reset in there before going again. Now, let's run over to Visual Studio here again. Stay in Visual Studio, I should say. And I just want to show you a code optimization script. Just a couple techniques in here. So one, up front, we did this yesterday. As soon as my object, before its first frame is ever even rendered, when this object first starts up, there's one called before start, called awake. We can use void start. This happens right before the first frame. Other objects are generally initialized by this stage. As of now, with the awake method, I only know that my object is awake. I have no idea if there's any other objects instantiated or not. In this case, it's early on in the process. I know I can get a reference to my own animator component. I'm going to use this all over. So I want to get that early, cache it up front, so I don't have to go back and forth asking Unity for it. Now this here, another one. When my game starts up, I'm doing this in start because now I know other objects likely exist at this point in time. In other words, I know my player is going to exist by the time my start method's called. Start is right before the first frame for this pumpkin is rendered. So I know that my main player at this point in time is already awake. It might not be rendered yet, but it's safe to call it here. I'm saying, find me my player. I'm caching that reference. Now, anywhere in my game, in this code, I can use player without having to search for it all the time. You'll find that some folks will do things in their update method like that. Every frame they're searching for it. Very, very, very bad for performance. Do this up front, cache those references, use them later. Again, caching reference here, I'm calling transform.position every time. The ideal way, and this is being called an update, it's happening every frame. The ideal way here is to go up top of my code and do something like this. Cache the reference to that transform. And I can use that later on without having to go back and forth between my code and Unity's native code. Saves on performance there. So all these places here, rather than using transform, I would be using my cache transform like that. So that's one way to save on those calls.
It's a good tip.
Now, finds. Just like we found our player in the beginning. So let me scroll up here. On start, I cached a reference to my player. I'm doing the exact same thing here. GameObject.find zombie kid. You don't want to do this every update. GameObject.find searches through every object until it finds one. Now this one here is a little bit more performant. This only searches objects that have a tag set on them. Find GameObject with tag, and I'm looking for my player. Again, I don't want to do this in update. I only want to do this up front. And as I showed you in the beginning here, my animator component, so if I right-click and I go to definition, I'm just creating a private variable here called animator. And when I wake up, I'm getting a reference. I'm calling get component. So it's a little bit slower. It's got to search that object for that component. I don't want to do that every frame. Cache it up front, and then wherever you use it in your code, you can just use that private variable and reference it. A couple little tips that go a really, really long way. Object pooling. Let's go back to that slide here. Object pooling and not searching for objects in update, cache those references can really, really help for performance.
Great.
All right, let's move on to almost to the last subject, terrain and skyboxes. We'll just talk about real fast here. Unity Terrain, it's got a really cool terrain system in there. When we get to the demo for the next section, Reducing Geometry, you'll show a quick demo on there.
Absolutely.
It's a cool system, but it generates many draw calls. So you can experiment with some of the built-in settings in Unity. They have some of these settings we can see on the slide here. Reducing pixel error can actually reduce the number of draw calls for terrain. Terrain is really hefty. You can drop a terrain in your scene. Next thing you know, you have 300 draw calls. Really draw call heavy. There are some really cool third-party tools. T4M, Terrain for Mobile, to help optimize your terrains. You're going to do a demo with TopoGun.
Yep.
Skyboxes. Yesterday, we looked at creating a sky in our world. Skybox has 6 images that get tiled around your world to make it look like you have a sky. That's 6 draw calls. KGFS Skybox has a kind of a cool little plugin that you can use, get from the asset store. That will reduce it down to 1 draw call. There's probably some manual methods you could do as well. For me, I love using the asset store. If I find a cool package on there, I download it and I use it quite repeatedly. In fact, virtually any studio, any developer I've ever talked to who's made professional games, they've got several assets they love from the asset store.
Great.
Lastly, reducing geometry. Some might say one of the most important subjects, this and reducing draw calls, right?
Yep.
Well, geometry, polygons and triangles in your game. It's important to know that polygons in your game are drawn using triangles. So when you model your character, you have what people refer to as polys in there. Those are actually drawn using triangles. Unity uses triangles. Your graphics card actually draws triangles. If we look at this cube on the right-hand side here, we can see this cube surface is actually 2 triangles.
Quad is 2 triangles.
Quad is 2 triangles. What a coincidence. So even 2D images use triangles.
And this is where that term tries, when you hear people
Tries.
go, how many tries are in your level?
Yeah.
What's the try count? That's triangles.
Triangles.
It's just a nickname for triangles.
On the right-hand side here for the cool logo Matt created, Zombie Pumpkin Slayer. Guys, I didn't hear you. There we go. Woo! Look at all of these triangles that make this up. Even a 2D image uses triangles behind the scene, how Unity determines how to display this.
And
So-
I think you can edit those as well. They have an edit function where you can go through and kind of reduce the amount of points around an image if you would like to reduce those. You can also do that in a 3D program as well, like Maya or whatever, if you're casting basically a UV over a certain area. That's just one way to kind of optimize certain things if there are too many tries happening.
Cool. There's various tools you can do. You can do them manually. You can go into your favorite tool to do it. There's third-party tools like Cruncher. I'll show you a quick demo of Cruncher. Mixamo has a neat one. Decimator. Blender has one built in you can get called Decimate. There's third-party services. One of them is simplygone.com, where you can upload your model up to a site. It happens online. Really, really cool. I mean, there's plenty of services out there that do it, different ways to do it.
Another term is retopologize. So you're going to hear that a lot.
Retopologize.
You would like to retopologize your model. Look for that in 3D programs, and that basically means it'll trace kind of a cage around a model, essentially, with a lower res. And you can kind of set that res and play with it depending on the package you're using.
Very cool. You can also draw a separate low poly model for your mobile. So maybe your console game or I would hope your console game has a different model than your mobile game.
Yeah.
Your console versus maybe your PC-based game versus maybe your mobile, tablet. You can have different models for that, each one with different levels of resolution in them.
Absolutely.
So you can do that manually or use tools like Topogun to kind of reduce that geometry. Level of detail. LOD is a pro feature in Unity, and that will allow you to take multiple models. So if you're up close to your zombie, for example, it's a kind of a high-def model. If that zombie's way off in the distance, why should you have to render all those? Why should I have to calculate and draw all those tries? So you can use LOD, level of detail, saying if it's a certain distance away, use that lower res model. When it's closer, show this model. Now, LODs is a pro feature in Unity, but there are scripts and plenty of ways you can find on the net that you can actually do it manually inside of code.
And that's great for games where you have tons and tons of like armies from a distance or different things like that. There's a ton of games out there that do that, and they'll actually have these really low-res models and thousands of them running around. But as you get closer, they pop in the high-res version so you can see like what they look like.
Cool. All right, let's move to our last demo for this session, reducing geometry. I'm going to show you a little quick tool that I like to use inside of Unity. It's a pay tool, so keep that in mind. Sometimes folks like some free features. The two tools that we're going to demo, I think you can get a trial of one of them. There's, again, many different ways to do this. You can do it manually. The problem that I found when I started game development, I don't endorse any of these particular products. They just happen to be things that I use. Because when I started doing development, I would find assets in the asset store that I would like. I would download them. And what I would find is that some of them really downloaded with really, really, really high poly count models. So, in fact, I was doing a game dev class, and this woman's like, oh, I got a shell from one of the third-party marketplaces for my game. And I looked at it, and it was like more than 50,000 vertices making up this little tiny shell. And I'm like, ooh, you have a couple of these in your scene. It's going to be really tough.
Yeah.
So, and that's the problem. Sometimes when you download these assets from the asset store, less on the asset store, because a lot of times you'll see the comments saying this is or is not good for mobile. But you get them from third-party marketplaces, and they're really nice models. And some of them are great for rendering scenes. You know, you might be doing an ad, and you want these 3D scenes in your ad. That's different than running a game. In a game, you really want to optimize that.
And these are where you're going to use these decimator or retopology tools. There's two ways of doing it. You can use a decimator tool that's going to use an algorithm to kind of manually compute what it thinks it should look like if it were a lower res or lower topology. Whereas if you use a manual tool like Topogun, or I think there's a couple other tools out there that do the same thing, but that'll let you actually manually go in and create the cage yourself around your model, so you can actually specify where you want less detail and more detail shown. And that's great for character design and sometimes even terrain, which I'll show you.
Very cool. So switching over to my computer here, let's look at, we're going to do Cruncher on this guy. So I've got this kind of more high poly dinosaur here. I mean, look at all of those beautiful tries all over the place here. Tries everywhere. So you can come in here and specify a target quality, convert, and behind the scenes, see, now this is much more optimized here. Less tries making this up here. It's non-destructive. It will actually go into your base model, and you'll find that you get different versions of it created that have different different poly counts on it. So you can tweak this out a little bit, change them around, create different ones, experiment with the settings on here, say, you know what, I do or don't like this particular, maybe this is too much for me. In fact, I remember the zombie kid I was messing around with the other day, and I made
way up and
took it way up, and he had like this little head that was this tiny little long cylinder. So you can actually go way overboard with this.
And sometimes you might not even, if you're doing low poly models from the start, like for example, our pumpkins and our zombie guy, they weren't exactly high res to begin with. They weren't a ton of tries. You might not even need to use these tools. These are specifically designed for when you have high res models and then you actually want to reduce the poly count and make them more of low poly models.
Yes.
This is basically what that tool's intended for.
Look at this dinosaur, right? This was initially pretty, there were little tries all over this model. I just cranked these settings way down, and look at this guy now. This is probably pretty good for mobile. One might even say you could probably go down a little further, and you can see you get this nice blocky effect here, which you'll notice on a lot of mobile platforms, but generally it's a smaller screen, so you don't notice it as much.
And when you use tools like Topogun, if you notice what it did to his head, it kind of distorted his head a little bit in that model. And let's say you wanted to make that a lot more precise. That's when you use a tool like Topogun, where you could essentially retrace that head how you want to with less polys and get more of the look of the character that you're trying to do in more of a low poly look.
With that, why don't you show us a demo?
Okay, absolutely. So we're actually just going to use the terrain in Unity. Let's see. Do we have the terrain export tool in here? Let's see.
Want to show folks where they can get that?
Yeah, absolutely. So if you go online and just search for terrain export script for Unity, terrain OBJ exporter in the Unity community wiki, just look for this specific script, and it's going to give you two versions. It's going to give you the JavaScript and the C#. I always download the C# script. That's just the one that I always kind of use when I'm making my stuff. So you just want to download that script. And where is the download for that script here? Or actually, no, I think you just copy it and make a new script and paste it into there. So we'll just copy this script. And we're going to make a new script. We have to put into, do we have a scripts folder in here? Actually, we have to put it in editor. We're going to make a new script. We're going to edit this script. Yeah, just double click on it to edit. Have this load up. Can delete all this. Paste in our new script that we got. We want to call this terrain. There's a name for it that we have to use, which is export terrain.cs. We'll save this.
Save that, rename it in Unity. Always good in Unity to make sure that your name of your objects, your classes, match the name that's inside of your editor. Sometimes you get some weird issues if you don't have it that way. And I think in this case, you can leave off the .cs on the end of that.
Oh, really?
I'm just kind of curious, did Unity take it off for you? Just out
Yeah,
of,
yeah, it automatically does that.
Cool.
So I have my new script that I got down there. You see where you get it online. Just go to the Unity community wiki, look for export terrain. It gives me this new option at the top called terrain right there, and that'll give me my export function. So we're just going to make a new scene here to demonstrate what we're trying to do. I'm going to create some Unity terrain. So we're going to go to our game object. Component. I forget, where's the terrain at?
game objects. Now they moved under game objects
changed it.
3D.
3D object. That's
They
right.
just
4.6.
reorganized these menus.
So we go to game object, we go to 3D object, we're going to go to terrain, make our terrain. And this terrain's pretty substantial in size, so I'm just going to bring that down a little bit in my settings, which is over here in your terrain settings.
Click on the little gear icon there.
Click on the gear. 2000 by 2000 is huge.
Huge.
So I'm just going to bring that down to 200 by 200. And the max height we'll just put at 30. Maybe 60 for now.
Sounds good.
Go back in on our terrain. And then we'll use the terrain tools over here to kind of sculpt this terrain.
Okay.
And for the interest of time, I'm just going to do something really quickly here. We're going to get a brush, increase the brush size, go on here, and just start making some cool terrain, right? So we go through here, we make some terrain, maybe increase the opacity, do some bigger terrain, and we'll raise this higher brush size, make the height a little higher than that. We'll do 30 on the height. Just go through and really start making these large mountains and different elements on here.
Pretty cool, just sculpting out some mountains on there.
Just sculpting out mountains and just kind of creating that terrain you want to create.
One of the few things that you can actually create 3D by default inside of Unity is the terrain. The terrain tools are pretty cool. As I mentioned early on, Unity is really not a modeling tool itself, not a 3D asset creation, with the exception of the terrain tools that are inside of there.
So I'm just kind of making this little area that we want that looks a little...
Cool, very cool.
And just to show you some different... Let's just make this down. We'll do some different height areas on here. All right.
That's pretty neat.
And that's always a good way if you're trying to make these kind of plateaus that you want your characters to jump down on and stuff. I always like to use the paint height tool, set the height, and then you can just kind of paint those heights. So you can have these multi-level areas that you want your characters to move on.
In other words, that just maxes out. You can't go any higher than a certain...
Exactly, and it'll even flatten it out for you too, which is great. So for here, I've got these different heights, and then I'm going to do another one that's maybe a little smaller. We'll do it at a 5, and maybe make it a little smaller so we can do like a crevice. I'll go through here, and we want this little kind of valley, right? And we want little areas in there that the character can kind of travel to and what have you. So we have this little kind of canyon that we've created right here. Now, when you use a decimator tool, there's things that can happen when you use that tool. One, let's say I want this very, very precise.
Because it's like an all or nothing tool, essentially?
It's an all or nothing tool. It kind of encompasses your geometry and it does an algorithm and it just does it basically all at once, right? It's not very precise. It doesn't know that, I want the edge of my cliff right there, always, and it has to be that way because I want, when you use a decimator, it might actually round this out even a little more. It might even round these out so it's not flattened here. There's a lot of things that can happen that give you unwanted results, right? But if you're using it for geometry that's in the distance or other things, it's great, right? It's more, I'd say, distance-related stuff. It's a lot better for when you use these automatic tools. But let's say I wanted this exactly like it is, but right now there's just way too much geometry to get this to run on, let's say, a mobile device, right? And I want to really, really make it as good as it should be. What I would do is I would use a tool like TopoGun. And you'll notice a lot of big industry companies use TopoGun to do their characters, do high-res characters that you sculpt in a sculpting program like Mudbox or ZBrush. You can actually take that down into a program like TopoGun, get very close to the same result with like a third of the geometry, or maybe even a tenth of the geometry that you had before. You bake all that detail in. I always like to use it for characters, and then I found, I'm going to try it on geometry too. Like, how good would it be? And I found that it's actually really great to give me more of that custom, precise geometry that I want when I'm doing a game, which is really, really great instead of using these automatic tools. Because I noticed I would use automatic tools like T4M and other things, and while they're awesome tools, sometimes they would give me unwanted results. So for what we're doing right now, I'll just show it to you in TopoGun and how I use it in my workflow. Cool. Here's the geometry I made. Just really quickly, we kind of threw this together just to kind of show you what we're doing. And in here, I'm going to export this geometry using that script that we got. You're going to get this new option up here called terrain. That won't exist unless you have that script in editor. You're going to use that export terrain.cs tool. You're going to use that, go export to OBJ. And OBJ is a 3D file format that you can open in.
One of the common formats, FBX, OBJ.
Exactly. And you can open this. Once I export to OBJ, I can open it in Maya. I can open it everywhere. And it's going to give me the actual geometry I want. And it's going to give you two options in it, too. It's going to give you the option to export it as quads or the option to export as triangles. I'm going to export it as quads because most 3D model programs that you use, you can actually model in quads, and it makes it a little bit easier.
Okay.
Triangles becomes more of a headache. Even though Unity uses triangles, it's good to export this in quads so you have more of an editable model that you can use.
I see.
So you can also export it in a specific resolution, and it will degrade it for you when you do that. So we're going to export it in full resolution with quads. Let's export our model. We'll export it to our desktop. We'll just call it terrain for now. Export that OBJ. And then it's going to save out that OBJ for you. And it's a really, really great script that somebody wrote for this. It really, really helps out a ton. Highly recommend it.
Thank you, whoever wrote that script.
Exactly. But I think his name's on that Unity wiki. So if now that we have our terrain exported, we'll close Unity. Well, let me close some of this other stuff I have. We'll go into TopoGun, and this is TopoGun. And TopoGun you can get on topogun.com. They allow you to download a trial version, but you can't save out anything, which is, we won't be able to save this out, but I can kind of show you how to do it in TopoGun. So once we're in TopoGun, the controls are very, very similar to Unity and or Maya. If you use Maya, you use Alt to kind of navigate around and come in and out. You can use F to focus on things exactly the same way. You're going to want to set up a project, which we had already done, and then you're going to want to load in your reference object right here. So you click Load Reference. And then from there, we go to our desktop, we find that terrain object that we created, and we load that in. Then it brings in that terrain, and there's our terrain we exported from Unity.
Wow.
See it right there, right?
So it sees everything exported, locate, imported, locate. That's a good sign so far.
And what's great with TopoGun is you can have models that have millions of polys on it.
Millions.
And it doesn't necessarily bring it brings in like I guess a reference of the model. It's not actually bringing the model, so it runs extremely fast. You're not actually editing the model itself. It's just kind of using it as a guide. And then on here you have your toolbar in TopoGun, which are these tools right here. And this is just the tool that I use. There's tons of tools available. I've just found this to be the easiest. And what's great about this is you'll notice if I exported that OBJ and brought it into a program like Maya, I would have to kind of visually model along the side of that model, which is really hard, where this tool allows you to model and just create, it kind of sticks everything to the model. So as let's say I really wanted to get this valley kind of looking how I wanted to, I'm going to grab my simple create tool, which is right here, and I'll start just creating verts. I can go along this model and just start kind of drawing out where I want these.
Kind of map out the lines.
Yeah, you're just making these verts as you go, these vertexes. And let's say you wanted to save polys, you could do larger vertexes. And do these, really get in there and add these. And then you can move them around too, like that one's a little up. And what it's doing is it's actually modeling alongside my model. And you can see why this is really great for characters or terrains or whatever. And you just kind of go through here and do what you want to do. And then you can go up and just start going up the sides of these hills, just kind of tracing out how you want this to look. And what's great is you're manually doing this, so you have full control over what you want this to look like.
So by modeling out just a region there, what are you kind of saying? I mean, you're outlining it, but that's just going to be like one optimized region, so to say?
Yeah, and when you're done, I mean, it takes a long time to actually use this tool. Yeah. It's a very time-consuming process, but the result you're going to get is going to be really, really beneficial to your game. So as you can see right now, there's probably 1,000, maybe even more, maybe 10,000 polys that exist within just this region alone. I can go through here, and as I trace that out, I can just start making the sides of those the way I want and actually just start connecting these and really helping. What's great is, I'm just going to use the side of this mountain as a reference just to kind of show you how this tool works. But as I go through, and just use the simple create, you want to hold down Control. If you're using this tool and you've never used it before, you're just holding Control a lot, clicking the points and just clicking from point to point to point, going through.
So multi-select Control in a lot of programs is used for multi-select.
Exactly.
Same thing.
And as it does it, it creates. And then I look at that, and I can kind of look at that, and go, oh, okay, that's pretty good. Maybe it doesn't have some of the advantages of the roundness of the hill, but it's pretty close to what I'm looking for. I saved
work great.
Mobile. It's fantastic for mobile. And I can come up here, and I can just kind of go in and start, adding in different elements that need to work for the geometry I'm trying to produce. And let's say we want the top. We wanted the character to be on top of here and just drop straight off and be more in line with what we were trying to produce. And same thing, you just kind of go in here and just kind of create those areas.
Fill that whole area in.
Fill it in, yeah.
You always have to fill in the area?
Always have to fill in the areas, okay. Because it's essentially modeling a 3D model as you go and you do this. So you just want to be kind of diligent and get in there and fill in all these areas. And so basically, as you go around and you model these vertexes and everything around your entire model, it's basically creating this cage of your initial model that's super, super low poly, from what you had. And what's great too is if you're using things like vertex shaders, once you're done with this, it's got great tools to let you bake all that information into that low res model. So you can actually take all that high res data, like the shadows and the cavities and different
wow.
things, build that into that low-res model.
So it looks great.
And it looks great, and you can use different shaders and everything. So it's a really, really great tool in order to just create more of a low-res version of a high-res model. I'm just going to go through here, just like here's that pathway. You just kind of go through, and then you can, use the bind tool here and just start going through and just creating these. And I use this all the time. Every day, I'd say I use this for custom terrain. You just get a better result than just a standard Decimator. And that'll allow you too, if let's say you had a really high detailed portion of the map, right? But the rest of it was maybe kind of flat, and you wanted to have a nice seamless transition instead of just sticking that one high-res piece onto your model. You can, create these really low-res kind of areas with just a couple of tries, and then have a super high-res, like take a lot of detail and build that out right next to it. So just wanted to kind of touch on this. It's a really great tool to go through.
Once you build it out like that, what do you have to do then to use it? To
get it? So all you do is, once you build the model out, and we won't build this entire thing, but it's just kind of an idea to show you how these tools work. It's just a really, really intuitive, just kind of easy tool. And the fact that it automatically kind of traces along your model as you go.
That's pretty cool.
It's just awesome. Like, I haven't seen anything that's as good as this. But really, once you're done and you have your model, let's say we've traced this entire map and it's exactly how we want. Or even, we only traced a portion of it and we didn't want all this stuff, right? We didn't want all this extra unusable terrain that's out here, and we wanted to just go along the edge, and we just kind of came through and just kind of did one of these around the edge and just cut this out, right? And we didn't want a messy cut like you do with just deleting a bunch of tries out of an OBJ, and we just wanted to kind of outline the edge of this map, right? You're just kind of going down here, and we're like, okay, that's good. We don't need all this extra distance stuff, right? You're like, that's perfect for my map. It's great. You can just model that, keep that all as one piece, and then when you're done, you just go to File, and on here they don't allow you. You just save your scene, put .obj as it, and it's going to tell you what folder you want to put it in, and you'll have that model. It won't put the reference with it. It'll just keep the actual model that you modeled in here. You'll have your OBJ. You can bring it into Unity or any 3D program.
Back into Unity.
You can bring it into Maya. You can do a little more unwrapping on it, do some different things to it, bring it into Unity, do whatever you want. You've got a great usable piece of geometry to use, and it's exactly the way you want it. So just a really, really good tool if you're trying to optimize high-res characters and you want them to look exactly how your high-res characters look, but in more of a low-quality feel. Or it's great for terrain too. Like here, you can go through, absolutely trace this entire terrain, make it exactly how you want with very, very little degradation, and more custom to the type of feel and look you're trying to do with less geometry.
You mentioned the word kind of unwrapping inside of Maya. That's just a process of taking the mesh of your 3D model, flattening it out so you can kind of paint on that 2D surface.
So yeah, you basically UV unwrapping. Let's say you have custom things happening on your model where you've got caves and valleys and different areas that, if you were going to do a standard projection and unwrap, like you wouldn't be able to get into those. You can actually get in, separate those out into different UV shells, kind of be conscious of where the seams of those edges are going to meet up and stuff, but have more of a complete kind of model with perfect stretch. There won't be a lot of stretching, things like that happening.
That's one of the things I noticed in the terrain built into Unity, that when you do that, if I have mountains and I start painting textures on them, those textures get stretched way out.
Exactly. And so if you want to get rid of things like that, a good way to do it is trace the model in a program like Topogun or whichever 3D. There's a lot of retopology programs that work. I just happen to use this because I think it's intuitive and very easy and very close to Unity as well. Once you're done with it, export the model, bring it into a program like Unity. Then you want to do your UV unwrapping in Unity, maybe in different shells, kind of be conscious of where the seams are going to be, where those UVs meet up, and then you have that texture map, then you can take that out, do more of the texturing in another program like Mudbox or ZBrush or whatever.
Very cool.
Export that, and maybe even use vertex shaders and different things to kind of blend it all together. So there's different ways you can do it. Yeah, but this is a really great tip on how to do that.
Great.
So.
Well, thank you very much. So this is hopefully an information pack. This is our longest session that we'll have of the entire series, but I think some of the most important information, so it's all very appropriate for what you're going to see.
Absolutely.
We're going to we'll be doing a 15-minute break. We're going to be coming back then after that with the next session. So stay tuned for some more exciting stuff today. Thank you very much.